Magnification calculations with lenses. So we are using the same two equations, the equation that has focal length and the distances, and the magnification equation. The the other differences have to do with what becomes a negative sign. So if the focal point that is used is in a diverging lens, then the sign in front of the focal point is going to be negative, because I'm using the focal point that's in the same side as the object but opposite from the observer. So that's why it's going to be negative. The object distance is always going to be positive, which seems kind of weird, but that's just the way it is. But if the image of the object, the distance of that, is in virtual space, then that will be a negative sign. So the positive sign, we always, whether we're talking about lenses or mirrors, the object is where the object is. We're just trying to figure out where the image is in relation to the observer. So remember that this kind of lens, this double convex, is a focal point has a positive thing, so the DO will be positive as well. So my first example, I have a 5 centimeter object and is placed 10 centimeters from a double convex lens with a focal point of 8 centimeters. Calculate HI and DI. So I use my first thing to find out my image distance. My F is going to be positive, so 1/8 is equal to 1 over DI plus 1/10. I convert them to decimals. I remember that 0.025 is equal to 1 over DI, so I have to flip it. DI is equal to 1 over 0.025. And I get the image distance is 40 centimeters. And it's positive, so that tells me that it's on the same side as of the observer. If this is positive, I'm expecting my height to be negative. So when I plug this in and I solve for HI, sure enough, I get a value that tells me that it's negative 20 centimeters. So the negative 20 centimeters tells me that my image appears to be inverted. It appears to be upside down. So just like with the mirror equations, if one of these is positive, the other has to be negative. So if my image exists in real space, then my height will appear to be inverted.